Assalamualaikum warahmatullahi wabarakatuh. Before I start the presentation, I want to introduce myself. My name is Lastri Wiani. I'm from University of Muslim Indonesia or UMI. Okay, and now I want to explain the result of our research about the effect of virgin coconut oil with orange juice ratio on the stability and viscosity properties of the emulsion. Okay, before I explain the essence of the research, we must know what is the VCO. VCO or virgin coconut oil is produced from fresh and mature coconut by mechanical or natural techniques without heating, so the nature of the oil is unchanged. And what is benefit of VCO? Benefit of VCO is the first VCO naturally contains a mixture of medium chain fatty acid or MCFA and long chain fatty acid or LCFA in a ratio of 3:1. And the next benefit, the highest MCFA content is lauric acid 45 to 55%. And the next benefit, VCO can help reduce total blood cholesterol, triglycerides, and phospholipids in serum and tissue. And the last benefit has a higher phenolic content and antioxidant activity. And next, we know many people don't like to consume VCO. Why people don't like to consume VCO? Because VCO have the oily taste in the direct consumption. What the problem of the VCO? The problem is looking for an alternative product that can reduce the oil taste when consumed. How to solve it? The solution to solve it is the development of a VCO-based emulsion product as nutritional food supplement will indirectly increase the consumption of VCO. And the next, I want to explain about the previous research. From Vianney et al. In 2016, we have been studied the ratio of VCO and water using a mixed emulsifier of twin 80 and span 80. And from Vianney et al. In 2018, we have been studied the addition of sucrose to VCO emulsion. And the last, from Vianney et al. In 2020, we have been studied first the addition of honey and citric acid, effect of antioxidant in VCO emulsion. In the next slide, I want to explain about the purpose of the research. Purpose of the research is to examine the effect of the ratio between VCO and orange juice on the stability and viscosity of the emulsions using three types of emulsifiers. Three types of emulsifiers is Arabic gum, xanthan gum, and soy lecithin. It is expected that the data from this research can provide useful information for the use of VCO and the development of VCO-based industries. And the next, I want to explain about the methodology of the research. Methodology of the research use 5 materials and 1 equipment. The materials have the first, VCO, orange juice, xanthan gum, Arabic gum, and soy lecithin. And the equipment using the ultra-thorax. And the next slide, I want to explain about the preparation of the research. Preparation of the research. First, make a mixed VCO with orange emulsion in the ratio 90:1, 80:2, and so on until 1:9. Then, add xanthan gum emulsifier mixture with ultra-thorax 15,000 rpm for 4 minutes. An emulsion analysis for its physical and chemical properties. and the procedure was repeated by replacing xanthan gum with other emulsifier or Arabic gum and sol lecithin. Next, from experiment about the research, now I want to explain about the results and discussion of the research. You can see the figure 1 on the slide. The stability of the VCO with orange juice emulsion using 3 types of emulsifier is present in figure 1. The use of soil lecithin in the emulsion results in unstable emulsion from the VCO with orange juice ratio 9:1 to 1:9. The emulsion stability using the emulsifier was only 16%. In emulsion using gum Arabic, the emulsion was stable with a ratio of 9:1. The more orange juice is added, the emulsion stability decreased. At a ratio of 1:9, the emulsion stability is 40%. In other words, the emulsion is unstable. This is different from the case with emulsion using xanthan gum, in which the emulsion stability was in the ratio of 4:6, 3:7, 2:8, and 1:9. The high stability was obtained at ratio of VCO with orange juice 1:9. The emulsion destabilization process begins with droplet movement. In large emulsions, droplet movement is dominated by gravity. The main factor affecting the creaming of the sample is the difference in density between the dispersing medium and dispersed medium. The greater the difference in density between the dispersing medium and the dispersed medium, the faster the separation due to gravity. The presence of an emulsifier can prevent or reduce separation. Emulsifier has a property that can blend oil or hydrophobic and a property that can blend water or hydrophilic. And the next, you can see figure 2 on the slide. The effect of using the type of emulsifier on the viscosity of the VCO with orange juice emulsion is present in figure 2. The viscosity of the emulsion stabilized by xanthan gum was higher than the viscosity of the emulsion stabilized by Arabic gum and sol lecithin. In an emulsion using xanthan gum at a VCO with orange juice ratio of 9:1, the viscosity was 230 cp. Then the viscosity increased. A very sharp increase occurred in the ratio 6:4 with a viscosity of up to 5,420 cp, which resulted in a very viscous product. Furthermore, the viscosity of the emulsion was further decreasing. When it comes to emulsion stability at a ratio of 6:4, this emulsion is unstable even though the viscosity is very high. At a VCO with orange juice ratio of 1:9, the viscosity was 1066 cp, which resulted in the most stable product. In the emulsion with sol lecithin, in the hex viscosity was 130 cp at the VCO orange juice ratio of 8:2. Then the viscosity decreased as the orange juice increased. In the emulsion with gum Arabic, the hex viscosity was 230 cp at the VCO with orange juice ratio of 9:1. This was the most stable emulsion. As the addition of orange juice increased, the viscosity of the emulsion decreased. At a ratio of 1:9, the emulsion viscosity is 40 cp. This difference is thought to be due to difference in the molecular structure of the 3 emulsifiers. In the chemical structure of xanthan gum, it has many hydroxyl groups that are able to bind water. Besides, it has many branches that make the trapped water is able to stabilize the resulting emulsion compared to Arabic gum and sol lecithin. And the next, you can see table 1 On the slide, Table 1 explains about the peroxide number of VCO with orange juice emulsion. In Table 1, the peroxide number of the emulsion with three types of emulsifier are listed. The peroxide number produced from the three types of emulsion has a lower value than the standard value issued by the Asian and Pacific Coconut Community or APCC. Namely, the maximum peroxide number in VCO is 3 mg per kilogram of sample. The low peroxide number is due to the fact that VCO contains around 90% saturated fatty acids, which are more resistant to residity to oxidation than unsaturated fatty acids. This low peroxide number indicates that the emulsion produced is not ranged so that it can be further developed to produce an emulsion product that is more delicious to be consumed. For example, with the addition of sugar, acid, or flavor that can enhance the taste. Okay, next, from the result and discussion of the research, you can conclude emulsion that has high stability is an emulsion that uses xanthan gum emulsifier. It produces a stable emulsion at a VCO with orange juice ratio of 1 to 9 with a viscosity of 1066 cp. Emulsion using Arabic gum produces the highest stability at 9 to 1 VCO with orange juice ratio with a viscosity of 230 cp. Meanwhile, emulsion using soy lecithin is unsuitable. Okay, that was the explanation of our research results. And the last, our biggest gratitude goes to the RPM of the Directorate General of Higher Education, Ministry of Research and Technology or National Research and Innovation Agency of the Republic of Indonesia for the funds provided through the Higher Education Leading Applied Research Grant for the 2019 to 2020 fiscal year. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh.